In this video, we're going over the Pythagorean Theorem. And the Pythagorean Theorem was developed by a guy named Pythagoras of Samos, who lived a long time ago from 570 to 495 BCE. And he's a mathematician from ancient Greece. And it is he who is credited by most people for discovering what we call the Pythagorean Theorem. So at its core, what the Pythagorean Theorem really does is it uses the squared lengths of each side to find a missing side, and this is only in right triangles with 190-degree angle. So if you have a right triangle, the hypotenuse is the side across from the square angle, and it's also the longest side of the triangle. So right there, that's the hypotenuse, and then this would be a small side, and this would be the other small side. So let's take a look at this in action, and we're actually going to see what the theorem itself is. So the theorem states that if you have side A, side B, and side C, and side A is small side 1, side B is small side 2, and C would be the hypotenuse. The theorem states that it's A squared plus B squared equals C squared. So that is the Pythagorean theorem right there. A squared plus B squared equals C squared. And let's take a look at what that actually means visually. So if we have A, B, and C, if we square each side, so if we take A squared, that's going to create a square using side length A. Same with B squared, so if we square that, that's going to create a square using side length B. And then C squared, same thing, it creates a square using side length C. So what the theorem means is if you take the area of the sum of the two small squares, that equals the area of the hypotenuse square. So again, if you have the area of square A plus the area of square B, that equals the same area of square C. And so whenever you see A squared plus B squared equals C squared, that is what it means. And you can use this theorem that if you're given two sides of a right triangle, you can solve for any missing side using the Pythagorean theorem. So let's go ahead and do that with actual numbers here. So we got small side 5, small side 12, and then C is unknown. So we're going to use the theorem to solve for side C. So if we have 5 squared, that's going to create a square right here. 12 squared, that's going to create a square right there. And then C squared, that square is unknown. So let's go ahead and use the theorem and figure out what side length C is using this. So A squared is going to be 5 squared plus B squared is going to be 12 squared equals C squared, which is still unknown. So now you're just going to solve this. 5 squared, 5 times 5 is 25, plus 12 squared is 12 times 12, which is 144. So that means we found the area of the smaller two squares equals C squared. So we add those together. 25 plus 144 equals 169. So that means the area of the larger square is 169 equals C squared. But again, we want the side length, not the area. So we still have to figure out what the length is that is. So that's just one step away. So to do that, we just have to square root both sides to cancel out the 2. Exponent, which leaves C. Square root of 169 equals 13. And so now we know that 13 equals C. So we can put 13 right there because 13 times 13 is 169. And the Pythagorean theorem is fulfilled. And so our final triangle right here is we have side length 5, 12, and 13. Let's do another example. And in this one, if we're given the hypotenuse and we have to solve for a small side, how do we go about that? And we're going to use the theorem as well, just a one step that's different. So let's go ahead and move our triangle over here. And now we're going to solve for side A using this theorem. So again, A is unknown, so A squared plus 12 squared, because 12 is B, equals C squared, which is 15. So now again, A squared is unknown, plus 12 squared is 12 times 12, which is 144, equals 15 squared. 15 times 15 is 225. So now we have A squared plus 144 equals 225. We want to isolate A squared, so we're just going to subtract 144, which cancels it out over here, and we're going to do the same to this side. So now we have A squared equals 225 minus 144 is 81. So we now know that the square of side A equals 81, but remember, we want to solve for the length, not the square. So we got one step left, is we got to square root both sides. So the square root of 81 is going to give us 9. So we know that side A equals 9, and now it's a completed triangle, 9, 12, and 15. So quickly, let's recap what we learned today. So we learned 3 things. The first is we learned what the Pythagorean theorem is, and it's A squared plus B squared equals C squared. Second thing we learned is how to use the Pythagorean theorem to solve to find the hypotenuse of a right triangle. And the third thing is we learned how to solve using the Pythagorean theorem to find a small side of a right triangle. And if you're interested in learning more about TurtlEd, visit us at www.withturtled.com.